All right, so you're all welcome to today's microeconomics session on the theory of consumer behavior. The theory of what consumer behavior. Okay, so let's start. All right, so let me start here. All right, so what do we mean by consumer behavior? Here, we want to look at how consumers behave in terms of getting goods and then what services, right? In terms of getting what goods and services. So consumers actually have a lot of goods that they demand, right? But because of their the limitation with respect to their financial resources, they are not able to get everything that they want, right? Because as a consumer, you cannot get everything that you want. So that's why I give some example that if you could remember, class, I said today the person will be like, oh, if I get bicycle, the person will be walking though, and the person is not having any gadget or device like the bicycle. So the person, when the person sees someone riding bicycle, be like, hey, I get this bicycle, I'll be so much happy. Tomorrow you get a bicycle, now you see someone riding motorcycle, be like, hey, this guy can move faster. With his motorcycle, he's able to move faster. But you see, with my bicycle, I'm not able to move faster. So the same person will be like, if I get motorbike, I'll be so much happy. So you see, we cannot get everything you want at the same time, right? So it takes time. That is why it will be prudent to know what is relevant or what you'll be able to acquire with your limited resources, right? So that consumers they consider prices of various goods as well as their resources, right, before choosing the best which suit their needs and desires, right? So this topic would examine the trade-offs that people face in their role as consumers, right? Because you're not able to get everything that you want. You're not able to get everything you want at that instance, right? Okay. So let me continue here. The theory of consumer behavior. All right. So this topic is very important, and I think it's one of the key topics that those who said they did a course at high school. I don't know whether you've been able to go through this topic as well. But even if you've gone through this topic, I think some other things might have added here, right? Okay. So now let's look at what the theory looks about. So it looks about utility, right? The satisfaction of what? Of consumers. Because you cannot satisfy a human being, right? Because today the person get this, tomorrow he wants that. So you see, it is not easy to satisfy consumers. All right, so utility. This is the satisfaction, right? So this is basically the satisfaction. The satisfaction that a consumer derives. The satisfaction that the consumer derives from consuming various units of commodities. Various units of commodities. Let's make it various units of a commodity. So various units of a commodity. So utility is basically satisfaction that a consumer what derives from consuming what various units of what a commodity, right? So consumers buy goods. Consumers buy goods because of the satisfaction that they expect. Buy goods because of the satisfaction they expect to receive from having and using that good. Right? So I'm saying that you and I will buy a good because we expect to receive some level of satisfaction from that particular good, right? I don't think any rational human being will buy something because of buying sake, right? But you buy it because you need some level of what? Satisfaction, right? So there are basically two schools of thought under this theory, right? Under the theory of the utility or the theory of the consumer behavior, right? So there are basically two schools of thought under this.
Are you walking around?
All right, so we have the Cardinalist, right? The Cardinalist view and then the Ordinalist. The Cardinalist school of thought and then the Ordinalist school of thought. The Cardinalist and then the Ordinalist school of thought, right? All right, so let's take them one by one. Let's take them one by one. Let's take the Cardinalist. All right, so the Cardinalist people are saying that utility can be measured in what? And in units called utils. They are saying that what utility? They are saying that utility can be measured in units called utils, right? And they believe that individuals can quantify. So they believe that individuals can what? Can quantify or value and quantify or value their satisfaction their satisfaction and quantify or value their satisfaction from consuming. Someone should please or a microphone. From consuming the good in monetary terms. In monetary what? Terms. Right? So they believe that we can actually quantify the satisfaction in monetary what? Terms. In monetary what? Terms. So they are saying that we can have the total utility, that is the total satisfaction to be derived from consuming the what? The goods. The total satisfaction we derive from what? Consuming the goods, right? So this is basically the total satisfaction we derived. The total satisfaction we derive from consuming units of the commodity. Units of a commodity. So they are saying that, for example, you have the satisfaction 1, utility 1 plus the utility 2, satisfaction 2 plus utility 3, and what have you, minimal, right? If you want to know the total satisfaction, you just sum or add all the various individual words satisfaction, right? So they believe that we can really quantify it, and you use the total utility, the average utility, the marginal utility, and the rest, right? So let's look at the average utility too. So they are saying that to get the average utility, that is the average satisfaction from consuming various units of the commodity, then it's basically there's the total utility, right? So the average utility, okay, let's write something. So this is the satisfaction derived per unit of commodities consumed. Per unit of commodities what? Consumed, right? So if they ask to find average, of course, it is per unit. Okay, so what is the formula for the average utility? Average utility here is the total utility all over what? The quantity, right? The average, and you have to get a total utility first before you can be able to get an average, because you are finding average. So it's the total divided by what? The quantity, right? All right. Then we have the marginal utility. Marginal utility, right? So marginal utility here, this is the additional satisfaction. This is the additional satisfaction. So anything marginal, if you hear marginal, it means that is the additional, right? Anything marginal, whether production or cost, marginal means that is the additional. So here, marginal utility means that additional satisfaction. When you go to cost, marginal cost means that the additional cost that has been added, right? So once you hear marginal, means that that's the additional something. So marginal utility, additional satisfaction. Additional satisfaction derived from consuming an additional unit, of a commodity. Right. Okay. So what then is the marginal unit? So marginal unit basically is the change in the total units all over the change in quantity, right? Change in quantity. So the change in the total units, because maybe the total units may have been 10. Now it has changed to 12, right? It has changed to what? 12. So in fact, the marginal unit can also means that change, right? Change in the item, because it can also decrease, right? It can also decrease. Because change means it can either increase or decrease. So change in the total utility all over the change in the what? Quantity. Change in the quantity. We can also use the differentiation formula, that is the TU all over the Q, right? Where the D here means that the differentiation. Finding the change, right? Finding the change. All right. So on that note, let's take an example. Let's take an example and see how we are going to handle it, right? Okay. So compute example. Example, compute the average utility. Compute the average utility and the average and marginal utility from the table below. From the table or below, right? So this is the table. This is the table. So we have number of balls of kinky. Number of balls of kinky. Number of balls of kinky. Then we have the total utility. Total utility. We have the average utility. We have the marginal utility. Right. Okay. So here we have 0, 1, 2, 3, and 3, 4. Right. So 1, 2, 3, 4. So total utility 0. Here 10. Here 16, 19, and 20. Okay. Here dash 10, 8. Sorry. I think we have to find the average, right? We have to find the average utility. So let's find the average utility instead. So that is the section that you have to find. That is the section that you have to find, given the number of balls of KK and the total utility. All right. So let's look at that.
Yo, Steve. You're going to win here. Yeah, go ahead.
All right. So now we are asking us to find the average utility and then the marginal utility. So which one should we find first? Which one can we find first? Hello, which one should we find first?
Please, average utility. Average utility.
All right, so average utility is what? The total utility over quantity, right? So what is the average utility for 0? What is the average utility for quantity 0? That is dash, right?
Yes.
All right, average utility for output 1.
10.
What is the average utility for output 1?
10.
So that's 10 over 1, right?
Yeah.
10 over 1. 10 over 1, and that is 10. All right. Average utility for output 2 is what? That is 16 over 2.
Yes.
16 over 2, right?
Yes.
So that is 16 over 2. That is giving us what? 8.
8.
Then average utility 3 is giving us what?
6.3.
Divided by 3.
19 over 3. What do we have?
6.3.
6.3. Then average utility for 4 is giving us what?
20 over 4.
20 over 4. And that is giving us 4, 5, 20, right?
Yes.
Okay. So now let's quickly find our marginal utility. Let's find our marginal utility. So what is the marginal utility formula? We said that the change change in what? The total utility over change in the quantity, right? So what's the marginal utility for output 0?
0.
So that is dash. Marginal utility for output 0 is what? Dash. What is the... So what did we get for here? What did we get here? We have 1086.35. That 1086.3, then 5, right? Okay. So marginal utility, we are saying that this one is dash. The marginal utility for output 1 is what?
10.
10 minus 1 over 1 minus 0.
10 minus what?
0.
So you are finding the change.
Yes.
It means that this 10 minus 0. So this is the change. 10 minus the 0. The new minus old. The new. This is the new one. Old one is 0. This is new. This is new. This is new. This is new. So here, new is 10. 10 minus 0. Please mute your microphones. 10 minus 0 all over 1 minus 0. So this one is what? 1 minus what? 0. 1 minus 0 as well. So the answer is what?
10.
Giving us 10. The marginal utility of output 2 is giving us what?
6.
That is what? 16 minus 10, right? 16 minus 10 all over 2 minus 1. So here the 16 is the new, right? Here the 2 is the new. So 16 minus 10. This one becomes the old. All right. So 16 minus 10 all over what? 2 minus 1. I'm sure we looked at the percentage changes when we were doing elasticity. New minus old all over old times 100. Did you do something like that? Hello, did you do something like that?
Yes, please.
Yes, please.
Okay.
Yes, please.
So 16 divided by 1. So 60 minus 10 all over 2 minus, what is the answer?
6.
6. Okay, the marginal utility output 3 is what? 19 minus 16, 3 minus 1. 19 minus 16 all over 3 minus 2, sorry. So what's the answer? I think it's 3, right?
3.
Marginal utility output 4 is given as what?
20 minus
20 minus 19.
20 minus 19 all over
4 minus 3.
4 minus 3. That is given as what? 1. Okay. So that is all for the marginal utility and the average utility, right? And all this that we are talking about is under the Cardinalist approach. Cardinalist approach, right? So can we fill the table? What's the marginal utility for output 1? What did you get for the first one?
10.
Second one?
6.
Third one?
3.
And the last one?
1.
Okay. Now let's move on to the... But before that, let's look at the law of diminishing returns, right? Law of diminishing returns. So law of diminishing returns. The law of diminishing returns. No. So the law of diminishing marginal utility, right? Diminishing marginal utility. Okay. So this states that all things being equal, this states that all things being equal, as several units. This states that all things being equal, yes, as several units of a commodity, as several units of a commodity is consumed. This states that as all things being equal, as several units of a commodity is consumed, as several units of a commodity is consumed, the extra satisfaction derived from each additional unit, diminishes over time, right? Diminishes over time. All right, so what does this law of diminishing marginal utilities mean? I'm not sure if you are satisfied, you continue to be taking maybe, let's say, water. If you are satisfied and you are okay, you will continue to take more of the water. So you say this say that as several units of a commodity is consumed. So let's say, you see, when you are thirsty for the first time, once you take in the first sachet of water, you see that you get some level of satisfaction. Let's say maybe you usually drink 2. Once you take the first one, you see that you are somehow satisfied. The extra satisfaction derived from each additional unit diminishes over time. So once you become somehow satisfied with the first one, the second attempt, you are not really, you see, the way you were eager to get the first sachet, you not use that same eagerness and that same strength to get the second one. Let's say the first one, you have to run to the provision shop to get it because you were really thirsty. Now the second one, you see that the second one, you're going to get it. Let's say you see that you'll be walking slowly because you feel like, oh, I'm not really thirsty like I was thirsty for the first one, right? You see that the satisfaction diminishes over time, right? That is what the law of diminishing marginal utility is saying, right? This is how we can have the law of diminishing marginality. We have the quantity of goods, right? And then the marginal utility, right? The marginal utility. Okay. So please, it is a straight line. Oh. Don't say it's a curve, right? It is a straight line, but because I'm using, and even if it was to be a whiteboard, I cannot even draw it to be straight unless I use a rule, right? Okay. All right. So the next thing is to look at consumer equilibrium. All right. So let's look at consumer equilibrium. A consumer can be in equilibrium when the consumer is using two separate words. Please mute your microphone. Mute your microphones. So a consumer can be in equilibrium when the consumer consumes what? Two separate goods. Two separate what? Goods. Right? So one, we have the single good, and then multiple goods. So that is a single good and a multiple goods, right? So under the single good, we are saying that the equilibrium, the consumer will get equilibrium when how much he pays for a commodity is equal to the additional satisfaction that he derives from that commodity. We are saying that the consumer will be in equilibrium when how much you pay, the price you are paid, the price that you paid for that commodity is equal to the additional satisfaction that you derived from that commodity. So let's say the marginal utility. So here we are talking of one good, so good X is equal to what? The price of the same good X. Because we are talking of one commodity. So we are saying that the consumer will be in equilibrium if the additional unit, additional satisfaction is equal to what? The commodity. The additional satisfaction is equal to the commodity. Please mute your microphone. Someone is giving me feedback. Right? So you are consuming. Okay, so let's talk about the single good. Let me bring it down here and talk about it. So for the single good, it means you are consuming one good, right? So the consumer would be in equilibrium if the marginal satisfaction or the additional satisfaction, the marginal satisfaction from consuming one good is equal to what? The price of consuming that same good, right? Then we can say that the consumer is what? In equilibrium for a single good. So if the price that you are paying is equal to the satisfaction, you say, oh, okay, then I'm satisfied. So being in equilibrium here means that you are okay, you are satisfied. Because if you are paying something more than like value for money, let's say you are buying the thing higher than even the benefit that you get from the thing, right? The benefit that you get from the thing is lower than the cost. You see that when you're buying, you are not happy. It's like you paying you are paying a very high amount for something that the benefit is small. You not even buy more, right? You not even buy more because and you will not be satisfied. But if what you are paying is equal to the satisfaction that you are getting, then you see that yes, I am satisfied. Yes, I am in equilibrium, right? So on that note, it means that if the marginal utility, the satisfaction that you are getting is greater than the price, would you continue to buy? Let me hear from you guys. Would you continue to buy? If the satisfaction
Yes.
that you are getting is greater than the price, would you continue to buy?
Yes.
Yes.
Why?
Yes, because I'm a rational consumer and I always want to satisfy myself and my satisfaction. If it exceeds the price, I'll continue to buy more.
Exactly. So you see, you even buy more. So you see, buy more. You buy more because, hey, I didn't have the thing is cheaper. Why? Because you are paying lesser for more benefits, right? You are paying lesser. It's like the law of demand. If the price is low, more quantity is demanded, right? That's why even the curve looks like the law of demand, right? So you can this one you can look into the slides for a better diagram, right? Okay. So you see, the consumer will definitely buy more of this because the satisfaction, the additional satisfaction, is more than the price. On the other hand, what if the satisfaction is lesser than the price of the good? What would the rational consumer do?
Buy less.
Exactly. That consumer will buy less. So this is for a single word, good. This is for a single good. Now let's go to multiple goods. Like you are buying something and something, right? Something and something. So for multiple good, I'm taking it from the scratch so that you would understand the reason for some formulas, right? Because if I just go straight to the point and I just did the formulas, that's where you would not understand. But taking it from the scratch. So once you are here and you join us from the beginning, then of course you should like this topic because this topic is coming to the exams. Highly probable that it will come to the exams, right? A consumer would maximize. So with a multiple good, we are saying that the consumer would maximize his personal satisfaction when allocating money or income in such a way that the last amount spent on the different goods, right? The last amount that the consumer will spend on different goods is equal to the marginal satisfaction, right? Is equal to the marginal what? Satisfaction. So here, we would say that so it's more than one good, right? So we can have good X and Y, right? Good X and what? Good Y. Good X and what? Good Y. So the good marginal utility of good X all over what? Marginal utility of X all over the price of what? The price of good X. And this will be equal to the marginal utility of, let's say, good Y all over the price of what? Y. So we can have more, right? Multiple good. We can have marginal utility of good X, Y, Z all over what? The price of what? Z. Right? And many more. And many more, right? Because you're having multiple goods, right? So this is basically how we are going to look at it, right? Now let's quickly move to the ordinalist school of thought and see how usually it's only the ordinalist school of thought that comes to exams usually, but we don't know what may happen this time around. Okay. All right. So what is the view of the ordinary school of thought? So they have the view that utility cannot be what? Cannot be measured, right? They have the view that how can you just quantify, stand up and then quantify your satisfaction? That you say the satisfaction is total satisfaction is the satisfaction 1 plus satisfaction. How would you get the satisfaction? Like they have the view that you cannot easily measure the satisfaction. It is impossible for consumers to quantify their level of what satisfaction from consuming what a particular commodity, a particular what commodity. However, this individual would prefer one good over the what other, right? So this individual would prefer one good over what the other instead. So they also believe that consumers' demand will depend on the preference and budget. Preference and what? And their budget. You only be satisfied if based on your preference and what and your budget. Hey, you don't have money, you want to be satisfied. You don't have money, you say you want Rolls Royce. You prefer Rolls Royce and your budget is low. Then you can't be satisfied. You can't be in equilibrium. So you be in equilibrium if your preference is equal to your budget. You prefer Rolls Royce, you like Rolls Royce, and your budget, your income, your money is low. You want to be satisfied. No. You have to get money, then you can say that I want Rolls Royce and my budget, what is in my pocket is equal to the Rolls Royce that I want, right? So your preference is equal to your budget. Then you can say that the consumer is in what? Equilibrium, right? So their budget or income is always represented using a budget line. We represent their budget using what? A budget line, something known as the budget line. Or the budget constraint. The budget, let me even use red pen for that. The budget line or the budget constraints. The budget line or the budget constraints, right? Okay, so how is the budget line expressed? So we say the budget line is your income. Say budget, the budget is your income that the money you have. So your income is equal to, the budget line is equal to what? So the price of good X multiplied by the unit of good X. The price of good X multiplied by the unit. If you want to know how much you have spent, is it not your price times the quantity? Is it not price and quantity that you know the amount that you have spent, right? So if maybe you purchase 20 units of what? 20 units of something, right? 20 units of something. You multiply the 20 units by price of each to get a total, right? So the price of that commodity multiplied by the quantity of commodity X. So here the commodity name is X. So price of commodity X multiplied by the unit of commodity X. The unit is the bigger X. This is unit, so bigger X. And the price of that unit is price with the small x under, right? Plus the price of good Y multiplied by the unit quantity. So if you are consuming 2 goods, then the price of good X and multiplied by 8 units plus price of good Y multiplied by what? 8 units, right? So usually we assume 2 goods. Usually we assume what? 2 goods. So here good X and Y. So this in the question, if the goods are represented by, let's say, A and B, someone should give me the budget line for a particular question. What do you think will be the budget line or the budget constraint for that particular question?
I equals Px of A plus Py P
Is that I is
Pa
equal
of
to
A Pa of A
PA of A
A
bigger A
plus
plus
Pb of B
PB of what? Bigger B. So the X and Y is not constant. If you go to the exam, they use, I remember in class we have been doing X and Y always. Every time we solve question, S and Y. We have solved S and Y. Some of the students went to the exam room only to see alpha and beta. I believe you know alpha and beta.
Yes,
You know alpha and
yes.
So you go there and see alpha and beta and you are saying, what is this? Is it a different thing from what we have been taught? Oh, madam. Oh, brother. It's just using I, saying that I is equal to P of alpha over multiplying the bigger alpha plus what? P of what? Beta multiplied by what? Bigger beta. Just like that. So just note what the symbol that they are using in that particular paper or that particular what? Exams. So usually here we'll be using X and Y, right? We'll be using X and Y. We'll be using X and Y. Okay. All right. So here, the I here is equal to your income. I is equal to income. The PX is equal to the price of good X. Hey, let me use black. Price of good X. Let me use black too. Price of good X. Price of good X. And then we have PY. Price of what? Good Y. Then we have bigger X is what? Quantity or unit of good X, right? You have the bigger Y is equal to what? Quantity or the unit of good Y. You get it? If you don't get it. Okay, so we have, all right, so let's analyze this. Let's look at this example. So let's say you have been given 1,000 income. This 1,000 income, you have to spend it on two goods, which is good X and Y. Good X and good Y. The price of good X is 600 cedis. That is each price. Our price per unit is 600 cedis. Price per unit for good Y is 400 cedis. How much of good Y do you think you can buy? So this is PY and this is what? PX. So how much do you think will be for the X? How much do you think for the Y? Find X, find Y. Yes, what's the answer?
It only takes 1 unit of good X and 1 unit of good Y.
No. Okay, so this is not you have to spend 600 cedis rather. You have to spend 600 cedis out of the 1,000. And so let me not say this one is the price. No, this one cannot be the price. Let me give the price. Sorry. So you have to spend 600 cedis for the 1,000, and you have to spend 400 cedis out of the 1,000. Now the price. Let me give the PX rather. PX is here 20, and then PY is let me make that one to 20. So find X and Y. Find X and Y. What do you think will be for X?
Find the quantity of X. I think we have to divide the total amount that you have to spend on good X over the price of good X, which will be 600 over 20, which is 30.
Is someone speaking?
Yes, please. Can you hear me?
I cannot hear you. Your volume is so low. Very low. I can hear that you are speaking, but very low. I don't know if I'm the only one. Can someone try that?
30.
Thank you.
30.
Which one is 30?
X.
X.
So X is 30. And then what of Y?
20.
20.
Y is 20. It means you can get a maximum of what? 20 units of what? X. And a maximum of 30 units of X and a maximum of 20 units of what? Y. So I'm sure this is basic math, right? You have 600, and the price of one good is what? 20. So just divide. This one, you have 400, and the price is 20. So you can get 30 here, you can get 20 here, right? Because since you are multiplying, so you just divide it, and then you get a unit quantity that you can get, right? All right. So how is the budget line like? The budget line is represented in this way. It's a line, right? So this is budget line. The budget line or the budget constraints. Good X and then good Y. Good Y, right? Good X and then good Y. All right, so now let's move to the slope of the budget line. You can see that the budget line is moving. Okay.
If you asked us to find
You mention your name first.
Rosa.
Okay.
Please, you asked us to find X, and you gave us the income, that's 1,000. Are we not supposed to substitute the values you gave us, that's the price and quantity, and we will find for Y. After that, we will substitute and find for X.
Oh, I think that will be a very long process. So you mean 1,000 is equal to P of X is what? 20 words.
And the quantity, that's
10 plus this one is what? Also 20 times what? Y. Right?
yes.
So something like this, right? You still get the same answer, but you are going to use a very long process. Yes, in fact, this is what we'll be doing. What you are saying is what we will be doing, but this one, without even wasting time like this, you should get the 30 and then the 20. So if you try that, did you try that? What are you getting? If you try this, what are you getting?
I thought you gave the quantity to be 600 rather, but I substituted this formula.
Yeah, you can see the currency there. Can you see the currency? I said, like, you are given 1,000, and you have to spend 600 on 1,000 out of the 1,000 on good X. Good Y, you have to spend 400 cedis out of the 1,000, right? So initially I made a mistake by saying PX, but it is not a P. This is the total amount you can spend on good X. Then you can also spend 400 on good Y. So if you add this, you are getting the 1,000. Then I gave a price for good X to be 20, and then price of good Y to be 20. So with that, you should be able to deduce the quantities for X and Y that you can get. I believe you are okay.
Yes, please. Thank you.
Welcome. Okay. So now let's look at the slope of the budget line. The slope of the budget. Let me even use red pen because it is very important. This is what you use in solving question. The question. Slope of the budget line. Slope of the budget. Slope of the budget line. Slope of the budget line. All right. So the slope of the budget line or constraint, let me write. This measures the slope of the budget line. We're talking about the slope. This measures the budget line or constraint. This measures the rate at which this measures the rate at which the consumer can trade one good for the other. Right? So the rate in which you can trade one good for the other, that is basically the slope of the budget line. So this is expressed. So the slope of the budget line is expressed. This is expressed as as what? Oh shit. As minus px. Let me use red pen. Minus what? Px over what? Py. Right? So why minus? Why? Because you are trading off one for the other, right? Because of trade-off. Right? So this is basically looking at the rate aspect, the rate bit, the budget, the constraint. Your budget is your income. So budget income means that we'll be talking about the price of the good, right? So this is the price of the good. So let us look at the changes in the budget line. What the changes in the word budget line? Changes in the budget line as a subtopic. Changes in the budget line. Changes in the budget line. Changes in the budget. So there are two reasons why the budget line can change. There are basically two reasons. Two reasons. What are they? We have one. When there is a relative changes in price. Relative changes in price, right? So this is where, let me add this. This is where the and this is when the price of one good. This is when the price of one good either increases, either what increases or decreases, either increases or decreases with the other constant, with the other. Okay, with the other constant, right? So price of one changes. So once it changes, it means either it will increase or decrease, and the other being what constant. So when that happens, we basically term it as rotation, right? Rotation. So let's say we have good X and Y. Good X and good Y, right? Initially, they were here. Oh, why is my hand shaking? Hey, I'm coming up. Let me see. All right. So this is better. So this is um, initially where they are, and I think that one of the good, there is a change in the price of one good, right? One of the prices what changes, either it would increase or decrease. So let's say the price of good X changes X. So this one is constant. Once the good X is constant, but then the good Y is constant. Sorry, good Y is constant, and then good X changes. So once it changes, it means that it will either decrease. It will either decrease, right? And then this one too. Once this one too, once it will either what increase. So once the price changes, price of one good changes, it will either what decrease or what increase. So when one side is constant and the other changes, we term it as what? Rotation. So if you go, you get an objective. What happens when there is a rotation? It means that the price of one good will change and the price of the other will be constant, right? So this is rotation. Rotation is like you are rotating, rotation. So here you are at one point and you are rotating. You are either going this way or you are either going that way, right? So that is why we are saying it is what? Rotation. Okay. Then the other one is,
I want to ask you a question.
other one is when there is a change in what? Income. When there is a change in what? Income. So income changes. So either the price will change or the income will change. So income changes and not change in income. Change in income. So when the income changes, what happens? So here we are saying that once there's a change in income, then that would lead to a total shift. It will lead to a shift and not rotation. So either the shift will go inward, right? Or it will shift outward, right? So here we are saying the budget line will shift outward if the consumer's income what increases. So the budget line will shift outward if the consumer if the consumer's income increases and inward, it will shift outward if the consumer's income increases, and then inwards if the consumer income what decreases. Right. Okay. All right. So here we can represent it with this diagram. What we mean is that there will be a total shift in the curve. So we are having something like this initially. So good X and then good Y. Once there is a shift in income or a change in income, there will be a shift. There will be a shift, right? Either inward, this is outward, right? This is outward. So it can be inwards as well, or inward. Right? Inward or outward. Inward or what? Outward, right? All right. So I believe from the first example, we gave income to be 1,000. Now assume the income changes to 1,200. Then expect that there will be a change in the what? In the curve, either shift inward or outward. So this one will lead to a shift. A shift. This one will lead to a shift. The first one led to what? A rotation. This one is entire shift when income changes. So this one is likely to even come in your eye, because under consumer utility, shift and rotation is a likely question to come. That what happens when there is a shift? And answer, they will say, what happens when income changes? They will say that A, there will be a rotation, B, there will be something, C, there will be something, D, there will be a shift, right? Yes. Another one can be what happens when there is a change in price? A, there will be a shift, B, there will be something, C, there will be something, D, there will be what? A rotation, right? So you should know this. Okay. Any question?
Yes, please.
Right.
Please, can I go on?
Yes, please.
With the slope of the budget line, can it be that we will be asked to find the slope from the budget constraint?
Oh, yeah. You find the slope of the budget line on the budget constraint.
That one, when you find the slope of the budget constraint, it would be positive. So does it mean that it's the same?
Does it mean that it is what?
It's the same as the negative px over py.
It is negative. Slope of the budget line is negative px over py. The formula for slope of the budget line is what? Negative px over py. That is it. It is not positive. Never positive. I know where you are coming from. I think when you are finding the equilibrium. So you see, this is negative px over y. And if you go to the slope of the indifference curve, I think we are yet to get there. That one is also negative. Negative mux over my. So the negative will cancel negative since there is an equal to sign here. So that's why usually we use the positive straight up. So Px is equal to over y is equal to MUX over MUY. So that because the negative will cancel the negative. But when the question asks you a separate question, find the slope. It is negative Px over Py. Right? So we'll come there. We'll come to the indifference curve soon. Right?
Okay, please.
All right. So now let's go to the indifference curve. Okay, indifference curve. So we are done talking about the budget line. We said that under the ordinalist, we are looking at the what? The preference and then the budget. Do you remember that? Do you remember that?
Yes, please.
So now we are done looking at the budget.
Yes, please.
Yes, so we are done looking at the budget. Preference. So the indifference curve, which is the preference. The indifference what? Curve, which is the preference. So we are done looking at the budget, which is the budget line aspect. Now let's come to the preference, because we said it is preference and what? Budget. So let's come to the preference bit. So the preference in the indifference curve is a locus. So let me write that an indifference curve is a locus of a combination. It's a locus of a combination of goods and services. Of goods and services that yields the same level. That yields the same level of satisfaction. That yields the same level of satisfaction the consumers. To the consumers. And therefore, he or she is indifferent. And therefore, he or she is indifferent as to which combination to choose. As to which combination to choose. Right? So here we are having combination of goods, right? And they provide the same level. They provide what? The same level of satisfaction, right? So because they are providing the same level of satisfaction, you are therefore indifferent because you don't know which one you are going to choose. That's why the thing is indifference. It means there is no difference, same level of satisfaction. So if they are providing the same level of satisfaction, what do you think is the best combination to choose from? Right? That is what we are talking about here. Right? All right. So note that this is also a likely OBJ question. Two or more indifference curve are called indifference map. Right? So this is the indifference curve. Let's just look at the diagram. A diagram to illustrate the indifference curve. This is the indifference curve. So So indifference curve. Right. So this is one indifference curve. And I'm saying that two. So another one, another one, two or more indifference curves. So indifference curve one, I see one, I see indifference curve two, indifference curve three. Two or more is known as what? The indifference map. So this is known as what? Indifference what? Map. This is a likely OBJ question. A likely OBJ question under theory of consumer behavior, right? Okay, so let's look at some of the properties of the indifference curve. Let us look at some of the properties of indifference curve. Properties of indifference curve. All right. So what do you think you can say from the looking at the diagram? What do you think would be some of the properties of the indifference curve? What do you think would be some of the properties of the indifference curve? What can you say about the indifference curve that you are seeing here? What can you say about it? That is the properties. Yes. Anyone to try?
It's convex to the origin.
Come again.
It's convex to the origin.
It is convex to the origin. Is it convex or concave? Is it concave? Is the word concave? I mean the word. And convex and what?
Concave. Concave.
Spell the word and let me see. Concave. Is it like this?
Concave. No L.
Yes,
No L. Oh, okay. So either it is convex or concave. Oh, okay. All right. So here you are saying that it is convex, right?
Yes, please, because it's bending to the origin.
Ayo, thank you very much. So it is convex to the origin, is right. What else?
It is negatively sloped.
Is convex to the origin. So I heard someone say it is negatively sloped. What else?
It doesn't meet.
Sorry?
It doesn't cross each other.
It doesn't cross each other. Wow. You mean the curves, right?
Yes, please.
All right. So the curves, so we can use, they do not intersect, right?
Yes.
So the indifference curves do not intersect. Do not intersect. Why? Who can tell me why they do not intersect?
Because each curve gives the same level of satisfaction, and if they cross, they they will they will it will not let us know the level of satisfaction the consumer is getting.
Ayo. Okay, so they do not intersect because They will even violate, but they would violate
the law of transitivity.
They would violate the law of what? Transitivity. The law of transitivity. Transitivity. Right? Any other? So we can also say every point on the indifference curve, every point on the indifference curve denotes what? The same level of satisfaction. What else?
Higher indifference curves depict higher level of satisfaction.
Okay, so higher indifference curve depicts what? Higher levels of satisfaction. All right. So I believe it is clear now. Okay. Now that we've spoken about the indifference curve and we know of the properties, then now let's look at the slope of it. Let's look at the slope of the indifference curve. So the slope of the indifference curve. We have looked at the slope of the budget. Now let's move on to the slope of the indifference curve. So the slope of indifference curve is what? This is equal to what? This is equal to the marginal this is equal to the marginal rate at which consumers and a consumer is willing. Consumers are willing to what? Substitute one good for the other. Right? So basically, that is talking about the MRS, right? Which is the marginal rate of substitution. The marginal rate of what? Substitution. The marginal rate of substitution. So what is the marginal rate of substitution? The marginal rate of substitution is the change in the marginal utility of X all over the marginal utility of Y. Marginal utility of Y, right? Okay. So that is the change. Now let us look at consumer equilibrium here. Let us look at consumer equilibrium here. So what did we say? At what point would a consumer be in equilibrium? At what point would a consumer be in equilibrium?
When the marginal utility of the commodity is the same as the price the person is paying.
Okay, right. As you said earlier. So a consumer is said to be in equilibrium when the indifference curve is tangent to the budget line. Is tangent to the budget what? To the budget line. Okay. So here, what we mean is that we already know how the budget line is. So let's first draw the budget line. The budget line we know is like this. Like this, right? This is the budget line, right? And we also know that the indifference curve is something like this, right? Now, the point in which it is tangent, right? Let me see. So, right? So, this we know is our budget line. And this we know is our indifference curve. So, the point in which they meet is known as the equilibrium that we are talking about. So, the point in which the indifference curve and the equilibrium, indifference curve and the budget line would meet, right? Then we see that the consumer is what? Equilibrium. It's at equilibrium. Because if your budget line or the constraint is equal to the indifference curve, then we can see that you are at equilibrium. That's why I initially said that if the preference is, we know is the indifference curve. If your preference is equal to your budget, your income, who needs to car or Botomutu per Rolls Royce? Is it possible? You don't have money, you say you want Rolls Royce. No. So if your money is equal to the preference, what you like, the Rolls Royce, then you can say that you are at equilibrium, right? All right. So the consumer would always maximize his satisfaction if it is only subject to the budget constraints, right? So at equilibrium, what happens? At equilibrium, then it means that at equilibrium, let me use red pen for that. Then we are saying that at equilibrium, what happens? Then it means that the slope of the indifference curve, the slope of the indifference curve should be equal to what? The slope of the budget line. Then we can say that that consumer is what? Is in equilibrium, because the consumer will always maximize its utility only if it is subject to what? The constraint or the budget line. So if that is the case, then what is the slope of the indifference curve? What is the slope of the indifference curve? I mean the formula.
Negative MUX over MUY.
Negative MUX over what? MU y. And this is equal to what? Should be equal to
Negative px over py.
should be equal to the slope of the budget line. And the slope of the budget line formula is what? Minus px all over what? The price of good y. Right. So now this is the what? The equilibrium point. Now because these two signs are equating, and we say negative is equal to negative, you see that one will cross and become positive. So if two negative signs are at opposite side, or there is equal to between two negatives, then automatically they cancel each other. So that's why we can say that, oh, then if that is the case, then the marginal utility of x all over the marginal utility of y is equal to the px all over the py. So this then becomes our marginal utility, right, at equilibrium. But if you are asked to find the slope alone, the slope of the indifference curve or the slope of the budget line, then you make sure you bring the what? The negative. Because if slope alone, it has negative. Yeah, it is because they are equating. That is why the negatives will cancel each other, as I said earlier. So they can ask you to find the marginal rate of substitution, right, which we looked at as what? As the slope of the indifference curve. And we are saying it is what? Negative mu over what? Over the mu(y). So negative mu(x) over mu(y). And since this is equal to the px, we said the slope of the indifference curve is also equal to the slope of the budget line, then it means that it can also be minus px over py. So if they ask you to find the marginal rate of substitution, it means we can either use this negative mu(x) over mu(y) or the negative px over py. Usually, I even prefer you use the px over py. Why? Because it is easier than using this one. They will all give you the same answer. Someone will use this one, you get the same answer as someone using this px over y. But the person who uses the px will do it within seconds. But you would now do multiplication, blah, 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 before you get the answer. This will just do simple workings. Okay. Any question before we take our first example? And the first example is a past question, right? Any question?
Sir. Hello. Hello.
Yeah, is someone speaking?
Yes, please. Please, I want to ask the marginal rate of substitution. Is the one where we've written mu(x) divided by mu(y) is equal to px over py. Can we also write it as mu(x) divided by px is equal to mu(y) divided by py?
Come again. Can you also write it as what?
mu(x) divided by px, which is equal to mu(y) divided by py.
Exactly. You can do it that. I think the first, the example that I gave, I think I did something like that, right? Where I said mu(x) over the px is equal to mu(y) over py. Then the last one is mu(z) over pxz, right? Did you see something like that? Yeah, I did something like that. So you can do that. You still get the same answer. All right. So let's take the first illustration or example. And this example is a past question, of course. So that is in Johnson's utility function for good x and y is given by. So I'll use this question to explain it to you, right? And I'm sure if you take any other past question, this is also a past question though, but okay, so given us it's a function for good x and y given by what? U, let me have this. Given by u into brackets x and y. X and y, right? Is equal to, no, let me bring this thing here. Given by u into bracket x and y is equal to x squared y cubed, right? Py and px, py, px, and I are the prices of good y and x, of good y and good x, and consumer income respectively, right? A, right? The budget, right? The budget constraint of the consumer, right? The budget constraint or the budget line of the consumer. So this one is also a requirement. So you can see that the question that came that they were having the alpha and beta. It means here, right, the budget line, they are expecting to see the alpha and beta symbol. If you use the x and y symbol, it means that you are on your own. Right, the budget constraint or the budget lines for the consumer, right? B, derive the demand functions for good x and y. Derive the demand functions for good x and y. C, what combinations? Someone is giving us some feedback. What combination of x and y maximizes the consumer's utility at I is equal to 100, px is equal to 2, PY is equal to 3. D. Calculate MRS between X and Y. Calculate MRS between X and Y at equilibrium. And interpret your results. E. Compute Johnson's total utility. I'm sure you've gotten the question, right? All right. So now let's answer it. So someone should read it for me. All right, someone should take it for us. Hey, who is reading?
Johnson's utility function for good X and good Y is given by
The lady should read.
Johnson's utility function for good X and Y is given by U into bracket XY is equal to X squared Y cubed. PY, PX, and I are the prices of good Y and X and consumer income respectively. A. Write the budget line or constraint of the consumer.
It's okay. So let's answer it one by one as you read, right? So A is saying that we should write the what? The budget what? Constraint or the budget line, right? So given the function to be what? U is equal to X, is it X squared? And then what? Y cubed. Right, so this is the function that has been given. U is equal to, what is the meaning of the U? If I may ask.
Utility.
Utility, right? Which means the satisfaction. Okay. So we have been given the utility, and then we should write what? The budget line. So the budget line here is what? I. So in this question, the income, they said I represent what? Income. P, Y, PX, and I are price of good X and Y and consumer income respectively. It means that I represent income. If you go to the exams and they tell you T represents income, maybe in your exams, in your paper, they will tell you that T represents income. Sister Akos and Brother Kofi, please, the question has given you its definition of income, and it's saying that the definition is T. Please use the T, even though you know the general formula. Maybe the examiner is trying to just worry you, right? By representing T as what? Income. So you know the general formula that I, here in this question, I are the prices of PY, PX, and I are the prices of good Y. So good Y is PY. good X is what? PX. And I represent the income. So note that the definition of this question is I. I'm teaching you all the tricks so that when you go and no matter how they twist the question, you'll be able to do it, right?
Yes, please.
Okay, so I is equal to, the budget constraint is what? I is equal to what? This question we have X and Y. So what will be the budget? I is equal to
Px multiplied by x plus py multiplied by y.
okay, so Px multiplied by what? X plus Py multiplied by Y, bigger Y, right? So here, I'm sure they gave us the value for the income. What is the income value? Can we see the income value? At option C, or question C.
Yes.
Okay, so that would be what? That would be 100,
100.
it's 100, right? Is equal to, what is the PX?
2.
PX is 2 and PY is 3. Okay. So PX 2 bigger X plus what? PY is what? 3. Multiplying the Y. Did you all get that?
Yes, please.
Okay. So this is the budget constraint that they are expecting. In fact, this is the actual answer. If you write this and you leave, it's wrong. This is what they are looking for. 100 is equal to 2x plus 3y. That is the budget line, right? But before that, you write this just to guide you. Okay. So the budget line is therefore 100.
May I ask a question?
Yes, you can ask.
Okay. So since the values came later in the questions, should we still use it at the first question?
Yes, please.
Okay, thank you.
They will always give you the values for I, Px, and Py. So you should always look out for it. Whether it is in the main question at the introduction part, whether it's in the second or last, you would have to always look out for the values given for that. Okay, so B, read a B.
Derive the demand functions for good X and Y.
So derive the demand function for what? Good X and Y. Some of the questions, they would skip the B and go straight to C. Some of the questions, they would skip B. So this is a standard question that I've picked. They will skip the B and go to C. But, you know, before you get to C, unless you do B. So if they say, find the C, I mean the question at the C, they ask you need to find the B first before you come to the C. But this one follows in order. So let's find the B. They are saying we should find the what? Derived what?
Derive the demand function for good X and Y.
To derive the demand functions for what? Good X and Y. So to be able to derive this function, so they actually want us to find the X and the Y, the function for X and Y. This X, so quantity, they are basically talking about the quantity, right? They are talking about the quantity, right?
Yes.
Yes, sir.
All right, so with this quantity, we know that before we be able to derive the quantity, the consumer must be in equilibrium. Before we be able to derive this quantity, because we said that the consumer must be in equilibrium before we be able to derive the quantities and the quantity of X and Y. right? Because we said the preference should be equal to the budget. Do you remember that? The preference should be equal to the budget. Do you remember that?
Yes, please.
Okay.
Yes.
So to know, let me write this, since this is the first time solving this question, a question like, but in subsequent ones, I will not write this statement. So to know the quantity demanded, to know the quantity demanded a person, to know the quantity demanded for a person, I mean for X and Y. So let me say for X for a person, okay, comma, and I said to know the quantity demanded, let me say the person should be in equilibrium. The person should be in equilibrium, right? So what do we say the equilibrium will be? We say at equilibrium, what happens? At equilibrium, we say that the slope of the indifference curve, is equal to the slope of the budget line. The slope of the indifference curve is equal to the slope of the budget line. So what is the slope? That is the minus MUX all over the MUY. Assuming this question is alpha and beta, MU alpha, MU beta, is equal to minus X all over what? PY. Here to be P alpha, P beta. Okay. So the consumer must be in equilibrium. Since they are equating, we cancel each other. Or we can just write MUX over MUY is equal to PX over PY, right? You can just write that and then you go. So now, how do we find the MUX? MUX is equal to what? When you are finding the marginal utility, we gave the formula to be a change in the total utility. Do you remember that? Over a change in the quantity. When we were doing the ordinalist approach, where we give the total utility and the marginal utility average utility. Do you remember this formula?
Yes, please.
Yes.
And then we said all the dTu all over dQ. That is using the differentiation, right? And I'm sure by now we all know differentiation, how to do differentiation. I think we did that under elasticity. I didn't do it with you though, but I assume that my boss did it with you, right?
Yes, please.
Okay. So MUX is equal to, we are going to use the differentiation. So we differentiate U with respect to the differential of what? X. Here the X is the quantity. So we are not going to use Q. It is not Q, it is X. So we find that du dx. It is the same as dtu, total utility, but we can just write utility, which means the total, yes. So the du dx, right? We are finding the differential of what? The differential of u with respect to the differential of what? X. So it means that we are going to differentiate the u function. We are going to differentiate what? The u function. What is the u function? Can we all see the u function? Can we all see the u function?
Yes, please.
So we are going to differentiate this, right? We are going to differentiate this. But look at the definition of the MU. We said MUX. So du, the what? The x. Look at the definition. The differential of u with respect to the differential of x. It means that anything without x, we ignore it. We are differentiating with respect to what? X. So anything that is not X, we maintain it as it is, right? We don't differentiate that one. So now it means you are going to I'm doing this because of those who don't know the differentiation, right? So we are going to differentiate the X portion alone, X squared. Why? Because we want MUX. We don't want MUY. We want only MUX. So what is the MUX? MUX, what is the X? X is what? X squared, right? X squared. So we are going to differentiate U with respect to X. When we want MUY, it means we are differentiating the U. We differentiate this one with respect to what? The Y. So we will leave this one constant. What we are not differentiating will remain constant. If we are differentiating MUY, I said we will differentiate the utility, total utility, with respect to what? The Y, and leave this one constant. But now we want MUX, which implies that we are differentiating U with respect to what? X. So the Y will remain constant as we differentiate the X squared. Okay. So now what do you think will be the definition for that, or the differential of the X squared? 2X will multiply the constant. Any variable standing alone, right? It means that we have 1 in front of it, right? We have 1x. You can't write 1x. You just write 1x, right? So all these, that any variable you have here is having 1 by it, right? So if you have 2x squared, it means here it is not 1 anymore. It is what? 2, right? These 2 will multiply the 1 here, and then you deduct 1 from it. That is it. That is differentiation. So we multiply the coefficient by the which word is that? The coefficient by the no. There's a, is it constant? There is a word here. Okay, so we multiply the coefficient by the 1 here, right? Or the constant, as you said. So we multiply the 2 by the 1. 2 by the 1. If you multiply the 2 by the 1, we deduct 1 from it, 1 from the coefficient. So I'm going to multiply these 2 by the 1 and deduct 1 from it. So that will be, you will be having 2x 2 minus 1. The coefficient will go and multiply the figure in front of the word variable. So that will be 2, then 2 minus 1. Then we are not differentiating the y, so the y will come as it is, y cubed. Can you see the y cubed? Can you see the y cubed? Yes, you can see it as it is. We are maintaining it like that. So what do we have? We have 2x y cubed. That is the marginal utility of x. We'll do the same thing for the marginal utility of y, which is equal to du with respect to what? Dy. So here we are differentiating u with respect to what? Y. Uy. So what do you think will be the variable? It means the x will be constant, right? So x will remain constant. So we have the x squared. Why? Because we are not differentiating u the x. U the x are not differentiating u. But we are differentiating the what? The y. So if you are differentiating the y, what do we have? The coefficient 3, sorry, the exponent, the word is coefficient. The word I want is coefficient. The exponent will multiply the coefficient. Here it is 1. Here it is what? 1. Here too it is 1. So this exponent will multiply the coefficient 1, and then you deduct 1 from the exponent. Then you deduct 1 from the exponent. So 3 multiplied by 1 will be what? 3. Then we have 3 minus 1, right? So what do you have here? You have x 2, 3, y 2, right? But you know having it in this form is not nice, right? Always the figures comes before the words, the alphabet, right? The figures come before the alphabet. So we would, since it is multiplying, it means that we can also have it like 3x squared y squared. Why? Because it is multiplying. So you can see that the x was held constant when we were finding the marginal utility of y, and also the y was constant when we were finding the marginal utility of x. Any question? Is anyone confused? Any question? Okay, that is good. So this is the marginal utility of x and the marginal utility of what? Y. This is the marginal utility of x and y. Now, we are going to put them into the equilibrium equation. So we said at equilibrium, what happens? The marginal utility of x. So what is the function for the marginal utility of x?
Two xy
cubed.
So 2xy cubed all over, is that mux over muy. So what is the function for muy also?
x squared 3y squared.
3x squared y what? Squared, right? That is it. So 3x squared yx squared, right? This will be equal to what? The minus px. This will be equal to what? The minus what? Px over what? Py. No, I think we've cancelled the minus, right? Why am I bringing minus again? Right? So px over what? Py. So now, if you have a function like this, what do you do? So how do we simplify this function? Because basically, do you remember I'm sure all of you here did core math, so you know indices, right? You know the basic rules of indices, right? Hey, Adamontiana, and I'm
Yes, please.
high school.
Yes, sir.
Yes, sir. Oh, okay. So, if you know the basic rules of indices, what do you think we do with this? When the I think when the bases are the same, you work with the exponent. You subtract, right? And then if it is this one is division. It's division, right? And the bases are the same. What do you think? You subtract. But I think that one will even be more complex. This one we can just say x will go here 1, and x will go here. X will go here, remaining what? Remaining 1x. So x will cancel here 1, and then x will cancel here, remaining 1x. Because x no back pen back cancel away. Now back 1x will cancel this 2x, right? And then we will be left with 1x. The whole of this will go here 1. It will go here 1, remaining 1y. I don't know if it makes sense. So what do we have? We have 2y, because there is no x here, all over 3x. Do you have, 3x? I mean, there is no y under 2. This will be equal to px all over py. Any question? Okay, so if there's no question, we continue. Now you have this 2y and then 3x, which is equal to the px and then py. What do you think we can do from here? We can cross multiply from here. Cross multiply from here. So if you cross multiply, you are going to get something like the budget line, right? You'll be getting something like the budget line. So what do we have here? We can have 3px, then the bigger x. If you multiply this and this, you get 3px and the bigger x. And that is equal to what? 2py, then the bigger y. If you cross multiply. I'm sure you are getting it. Are you getting it?
Yes,
So from here, we do cross multiplication. If you get this, we do cross multiplication. And if you do the cross multiplication, 3x multiplied by px. So you are getting this. So here, I just brought the px before the bringing the bigger x, just to represent the I is equal to px plus y is equal to what? Py. Plus py and then the bigger y, sorry, right? So that's how I've done it, right? With this, we want the function. What is the question demanding? Write the functions of x and y. We divide both sides by, so which one should we find first?
X.
Let's find x first. Okay, so if we want x first, we divide both sides by 3px. 3px. This 3px will cancel this. And then our x function will be x is equal to 2py bigger y over 3px. You see, it's not difficult. Not difficult, very simple. Right? So the x function is this. So this becomes equation 1, right? This becomes equation 1. Or the same, you can wait. So now we do the same for y. How do we find y2? Well, if you want to find y2, it means that the y will still be having the 3. We'll still be having the 3px is equal to the 2py. Divide both sides by, we want y, right? So we divide both sides by 2py. This one will cancel this. What is our y? Our y is now equal to 3px bigger x all over 2py. So have we answered the question? Have we answered the question? The question says we should do what? Hello guys. Yes. The question says we should do what?
Derive the demand function of both x and y.
Have we done that?
Yes.
Yes, we've done that. We have derived the functions. The function is not a figure. It is a function. It is a function, right? With variables. So therefore, the demand, therefore now, baby. Therefore, the demand functions for x and y are so for x is equal to what? X is equal to what? P. Let's go 2py 3px 2py with bigger y, Anna. 2py bigger y 2py bigger y over what? 3px. And then what is our y? Our y is equal to what? 3px
Bigger x.
Bigger x. all over what? 2py. What been?
Please,
Okay, so now, yeah.
So where we have the px and the py, can you just input the values, or you don't have to do it?
Where you have what?
You see we have 3px and the bigger x, and then over 2py. So I'm asking if you can just input the figures for px and py, or you don't have to do it that way.
Don't do it that way. They are only asking for functions, right?
Okay.
So you don't input the values. You just get the function like that and then leave it for them.
Thank you.
You're welcome. Okay, so now we are done with the B part. Let's move on to the C. So the B here, before you get a C, you need to do the B. That's for some questions, they will not ask you to find for the B, derive the functions. In some questions, some of the past questions, they will not actually derive the functions for, they assume you know already. So they just go ahead and ask you, find the values for X and Y. That is what is the requirement for C?
What combination of X and Y maximizes the consumer's utility? At I is equal to 100, Px is equal to 2, and Py is equal to 3.
So what combination maximizes the consumer's equilibrium, right? Consumer's utility, right? So here too, we say that at equilibrium, what happens? So at equilibrium, we know that, so assuming they ignore the B, they ignore the B question, and we are starting the C, we would have said that at equilibrium, the slope of the indifference curve is equal to the slope of the budget line, and then continue from there. When we get the answer, we continue, right? But we have already done that at equilibrium, right? So here, we are just continuing with what we started. So for the consumer so here we would have said to maximize utility, what happens? The slope of the indifference curve is equal to the slope of the what? Slope of the budget line. But we have already done that and gotten our functions. So now that we have the functions, we will just substitute. So let's make the functions. Let's see. So the budget line, let's make the budget line equation 1. Where is the budget line? This is the budget line with the figures, but let's make this one equation 1. Because it is with variables. And let's make this one the X that we found. Where is the X? X. So X will be equation 2. Move on to the Y. Y is equation 3. So how many equations do we have? How many equations do we have?
3.
3 equations.
3 equations, right? Okay. So we say that substitute, we can substitute equation 1. What do you think we can do to get the so someone can say, yeah, the C, the action has to find the value of X. The C.
Yeah.
C, the meaning of the C is that we should find the value of what? 2py and then the y all over 3px. Given the values, you said we've been given the values. So 2. What is the py from the question?
3.
It's 3. So the one who said we should use it. What is the value of the bigger y? What is the value for the bigger y? We don't know. Now we come here, 3px. What is the value of px?
2.
2. In the same way, if you want to find for y, we have 3px bigger x all over 2py. Now, 3px, px is 2. Is it 2 or 3? 2. The bigger x, do we know the value? No. Which of them is y? Is it py or
3?
I think the 3p, is it 3py? Or 2py rather? Here is 2py.
Yes, please.
Okay. The py is what? 3. Do we still know the value of x? No. So we cannot just put the figures inside. Because if we put the figures inside, we don't know have the values for the quantities. Right? They didn't give us the value for the quantity. We are yet to find the value for the quantity. Right? And that is why we cannot just input the figures in it. So the one who asks, can't we just substitute the figures in it and then go ahead? This is the reason why we cannot just put the figures in it. Because if you put the figures in it, you will still be needing the quantities for x and y, which you don't have. So we are just going to do change of, no, not change of subject, substitution, right? And then we'll get a function whereby we will not be needing the x and y here. We need to get functions whereby x and y will be here so that we can just input the values that have been given in the question, right? So that we can just input the values given in the question. So now, we can say that put equation 2 into equation 1. Substitute equation 2 into equation 1. So substitute equation 2 into equation what? 1. What is the equation 1? Equation 1 is what?
3x plus 2x. Okay, px plus py.
No, equation 1 is the budget line. That's the budget.
Equals 3x bigger x plus
px
2y
plus py.
Okay, so px bigger x plus what? Py bigger y. So if we are saying that substitute equation 2, equation 2 here, there is the x. Equation 2 is x, right? The function for x, yes. Right. Can you see that?
Yes, please.
So equation 2 is x. Equation 2 is x. So it means that wherever we see px, what do we put there?
2py all over 3px.
It means that I is equal to px is given as what? So px
2py all over 3px.
wherever we see y, we put 2. Did you say 2?
Is
2p
y and
y
the bigger y
and the bigger y all over
3px.
all over
There's more
3px.
x. Yeah.
Yes, there's more x. Okay, thanks. Plus the py and the bigger y, right? Plus the 3y and the what? Bigger y. So now we can do simple cancellation here, right? We can cancel this one and then what? This one. Right? This px will cancel this px. So what do we have? We have I is equal to what? 2py bigger y all over what? All over 3 plus what? Py bigger y. You get it?
Yes, please.
Okay. So px will go here 1, px will go here what? 3 times. That is why I just said this one will cancel this. Right? So 3 times. Okay. Now, what do we do from here? So from here, we have the exponent. So we can multiply through by the denominator, right? Because we want to cancel this denominator. What do? We multiply through. So both the left-hand side and the right-hand side. So left-hand side will go 3i. That is equal to 3 times 2py y over 3 plus 3py y. So this one will cancel this, right? This one will cancel this, right?
Yes, please.
Yes.
Okay. And then this 3 will multiply this. So what do we have? We have the 3i is equal to 3i is equal to what?
2py.
2py bigger y plus what? 3py bigger y. So 3i is equal to 2 plus 3, 5 py bigger y. You have 2 oranges here and you have 3 oranges here. Can't you add the 2 to get 5 oranges? You can do that, right? So then what becomes our, you divide both sides by 5py. 5py. This one will cancel this. What is our bigger y? Our bigger y is equal to what? Our y is equal to what? 3i all over 5py. What then is our 3i? We know our income to be given in the question as what? Is it 100? Is the I 100?
Yes, please.
Yes.
So 100 into bracket 5. What is our py?
3.
3. So what is our y? So in the same way, we can say substitute.
20 units.
So it's what? 20. So
Yes.
y is equal to 20 what? Units. 20 units, right? So you are saying that substitute what? Equation 3 into what? Into equation 1. Or even without doing this, we can just put
Please,
that would even be sorry?
Y is equal to 25 because you divide 300 by 15.
You divide 300 by 15. So y is equal to what?
25.
No, it's 20.
It's 20.
It's 20. Okay.
Yes.
So now, without even substituting, now that we've gotten y, we can find our what? X. So what will be our x? What is the x function? X function is given as what? 2py y over 3px. Now that we've gotten the y, we can find the x function straight up without substituting that one into the long equation to be a long word. So 2py bigger y all over what? All over 3px. Can you see that? All over 3px. So with this, we can say that what is our y? Y is 3 and our price of y is 3. And then what is the unit for the y? We said we had 20. Unit for y, we said we had what? 20. All over 3 into bracket. What is px?
2.
So what do we have for x? Now we want the marginal rate of substitution, which is the next one, right? That is the next one. Marginal rate of substitution. I'm sure that is the next one, right? Calculate the marginal rate of substitution for x and y. The marginal rate of substitution is basically is basically the MRS. So it's minus MUX all over MUY. And this is equal to minus PX over PY. Because of time, I'll use the PX over PY. So let me use the P minus PX. So it's equal to minus PX over PY. What is the minus PX? What is the PX figure?
2.
2 over PY.
2 over
3.
3.
What's the answer?
3.
The answer is what in decimals?
0.67.
0.67. Right?
So
negative 0.67. They say interpret. This means that if you are interpreting this, it means that for every unit of, or we can still use this to interpret it, is it that for every unit of interpretation, for every unit of unit of good Y, the consumer must forgo. You foregoing means you are negative. In a cons, foregoing means negative. Must forgo 1 unit of good X. Or someone can also say that for every unit of what? For every unit of good Y, the consumer must forgo 1 unit of what? No, 0. Sorry. I mean 0. Must forgo 0.67, right? 0.67. Or for every unit, or for every 3 units, for every 3 units of good Y, the consumer must forgo 2 units of good what? X. That is the interpretation. So go and try this. MUX. Put the functions in it. The function which is 2 something something y squared negative and do it. You still get a 2 over 3. Go and try that too, right? Now, the next one is E. Find the utility, which is U is equal to x squared, x squared, and then y cubed. Yes. So what is x squared? X, we have 20. 20 squared. Then y cubed, what did we get for y?
20.
That is also 20. It is not always the same, but this one, we are fortunate it's the same, but not always the case. So 20. So that is the total utility, total satisfaction. If we want the satisfaction, that's the total utility satisfaction. That's the answer. So if you do that, then you say therefore Johnson's utility function is what? Blah 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 blah. So that is it. Thank you very much and have a wonderful day. So the recording would, when do you have the paper?
20th.
20th.
No, I mean the
20th March.
but there's some quiz.
20th.
I can do some quiz. It's on 20th, Tom.
No. The
Yes.
quiz we are supposed to submit it before on
Tomorrow and 8.
Tomorrow and it's the quiz that I'm talking about. It's the quiz that I'm talking about. Okay, so let me end this recording. Thank you all for coming, and I would make the recordings available to our YouTube channel. And then I will make this document also available. So on that note, thank you all for coming. I'm sure all of you are fine and you don't have any question, right? You don't have any question? If you have any question, you can text it to me or do a voice note, and I would also do a voice note to reply you. In the absence of any question, thank you all for coming and have a wonderful evening. Bye-bye.
Bye.
My laptop means I make you one.